Heating effect of electric current. Touch your cell phone which has been charging. Touch the CPU of your computer or the television or the mixer which has been running for some time. Do you feel heat? Why do the electrical appliances get heated when we use them? This happens due to the heat generated as a result of heating effect of electric current. Let us learn more about it. What do you mean by the heating effect of electric current? The energy can be transformed from one form to another. When current passes through an appliance such as mixer, it gets electrical energy. What happens to this energy? Where does it go? Some of the electrical energy supplied to the mixer is used for its mechanical function of rotating the blades, whereas the rest of the energy is released as heat energy, making the mixer warm. This process of transformation of electrical energy into heat energy due to electric current is known as heating effect of the electric current. Why the heat is produced on passing the electric current? Let us understand this with the help of a circuit with a battery. Conducting wires made up of copper and a resistor made up of nichrome. When the current is passed in the circuit, the nichrome wire is heated red hot, while the copper wire is hardly heated. To know why this happens, we have to compare the structures of the materials. The copper wire has a network of positively charged ions, that is, the atoms which have lost their electrons. These ions can vibrate, but they cannot move freely. Then there are a large number of free electrons which can move freely. The nichrome is an alloy of nickel, chromium and iron, and so it has the network of 3 different ions. But the number of free electrons in nichrome are lesser as some of the electrons are involved in bonds with different atoms. These bonds also restrict the number of pathways available for free movement of electrons. So, when the current is passed, the electrons in copper flow easily and a few of them collide with the vibrating ions. In nichrome, the electrons cannot move ahead easily as they are resisted by the bonds. Most of these moving electrons collide with the vibrating positive ions. During these collisions, the energy of the electrons is transferred to the positive ions, and the ions begin to vibrate more vigorously. This energy is released in the form of heat. The lesser number of collisions in copper release very little heat energy, and it can hardly make the copper wire hot. Whereas a large number of collisions in nichrome release much higher amount of energy, making it red hot. Heating effect of electric current is also known as the Joule's heating, because it was first studied by James Prescott Joule in 1841. Joule's law of heating states that the heat produced in a conductor is directly proportional to the square of the electric current I passing through the conductor. It is also directly proportional to the resistance R of the conductor and time T for which current passes through the conductor. It is given by the expression H is equal to I square into R into T, where H gives us the amount of heat generated. Based on the Joule's law, we can say that to get more heat generated, we have to pass more current for more time. As the resistance is directly proportional to the heat generated, the materials that have higher resistance to electricity, such as nichrome or tungsten, generate a large amount of heat as compared to copper. This property of tungsten and nichrome is used in several appliances where electrical energy is required to be converted to heat energy.